So yeah, for my introduction, my name is Abe Wanjeri. I'm a design engineer for Morrison Utility Services. I work for the utility division, water side. Today, I'll be discussing with you SUBLINE-DR, also known as closed fit lining roll down. So what is SUBLINE-DR? SUBLINE-DR is a technique where a standard PE pipe is butt fused into appropriate sections and is taken through a set of rollers and reduced to a diameter of 10%. This technique is a bit different from convection slip lining, because what you have in this section is once you reduce the main by 10%, it allows you to actually insert the main in a existing host pipe, which you'd consider a bit more smaller than the existing pipe you're slip lining. Now, in this technique, what happens is the main is not put under any tension application, unlike convection slip lining where the main is actually winched through the host pipe. Once the main is actually pulled into the host pipe, the main is then pressurized with cold water, which reverts it back to its original diameter. Now, this technique is very new to the industry. However, it's been used in different industries as well. And today I'm going to be giving you an example of how I came to propose it in one of the projects I was working on. So I was assigned a project which involved renewing a 20-inch cast iron main and a 16-inch span iron. Now, the client made it clear that they would prefer if I could maintain the current network performance, and also they went on to mention that they were working at a tight budget. In this case, the first thing I did was to undertake feasibility studies to understand the condition of the existing main, and there's no better way to do this than to obtain a pipe sample. So when I received the pipe samples, as you can see there, the internal diameters was 512 millimeters for the 20-inch cast iron main, and 16-inch, and for the 16-inch span iron main, the internal diameter was 427. By obtaining this information, I was able to come up with proposals for solutions, and one of the solutions I came with two scenarios to address the problem. Now, in this case, the scenario one, as you can see over there, is I had the 20-inch cast iron main being replaced with a 500 millimeter polyethylene pipe, and the 16-inch main being replaced with a 400 millimeter polyethylene. In scenario two, I had 20-inch being replaced with a 400 millimeter PE, and the 16-inch span iron main being replaced by 355 millimeter PE. Now, in such a situation, the reason why I came with these proposals was taking into consideration the tight budget I was working with. It made sense for me to consider slip lining first and open car, in other words, open trench, as the last option. But to verify my proposals, why did I commenced a hydraulic performance analysis, which would compare the current network performance with my proposals. As you can see here, what I have is the first scenario where I had proposed the 500 millimeter PE for the 20-inch and 400 millimeter PE for the 16-inch. As you can see, the network performance is pretty much similar or even better than the current. These are the velocities, as you can see, There's high velocities on the 16 inch with the first scenario, and when it comes to the flow, it's pretty much even. The same thing goes for the 20 inch. The velocities are a bit higher. This is due to pipe reduction slightly, but the flow is pretty much the same. As for the scenario 2, due to the main be even smaller, my proposal being even smaller, in this case, renewing the 16 inch with a 400 millimeter PE. So there's higher velocities experienced, and also the flow, as you can see, is much more reduced as compared to your current performance. The same thing was experienced for the 20 inch. The velocity is a bit higher, but also the flow as well is less as compared to the current. So for me, it made sense to go ahead with scenario 1, and what better way to implement scenario 1 than to use Sublime-DR. Now, I must say is, based on the pipe sample I actually received, it was very evident that implementing scenario 1 with convection slip lining, due to the small clearance of the main, the main would be damaged, and to prevent this, SDR was the appropriate method to go ahead with. Now, in this case, what happens is I would have the main, an example for the 20 inch main. So I'd have the 500 PE main reduced by 10%, which is actually 450 millimeter PE, slip lined through the 20 inch, and once slip lined, I would have the main pressurized back with cold water to its original diameter. Now, I was able to present my findings to the client and all stockholders involved. However, there was some backlash from the operation team, from the client's operation teams, because this was new to them. They were a bit reluctant because due to future repairs and future connections. The issue was the fears were raised from the operation team, were if the main did not revert to its original diameter, thereby they would have to get custom fittings and to replace or repair the main in future. However, since the main goes back to its original diameter, you'd not need any custom fittings. Now, I do understand where their fears originate from, having used previous innovations where they've been forced to use custom fittings to do repairs or connections. I also even went ahead to give them confidence by contacting the supplier to offer them a demonstration to see how the technology works, and so they can see it physically as well. Also, I also provided any information that could give the guys, the client operation team, more confidence to apply, to use Sublime-DR. I gave them a week to make a decision, and in which they came back and decided to use they came back and decided to go with scenario 2. Now, the reason why they decided to go with scenario 2 was due to the influence from the operation team, still harboring fears of future repairs and maintenance. I do respect the client's decision. However, for me, I felt this was a missed opportunity to actually maintain the current performance of the network, and this would have helped the client down the line in case there was any future developments in the area. However, I do not look at it as a bad thing, because everybody is wary when it comes to new innovation as well. And I believe in the future, if they're faced with a scenario similar to this, they may consider using this new technology. Now, before I close my presentation, this is something that happens a lot in the utility industry, but also in the world of technology. I believe for successful implementation of innovative solution, it's very important for everybody in the company to be involved, because if one department is involved and they prefer the old way of working, do us because it benefits them, that way it sort of impacts the success of the implementation. But if when having everybody on board, including the managers and everybody involved, I believe this would have changed the final decision. Another thing is being open-minded in terms of attending events set out by manufacturers and suppliers. This is very important because I myself do attend those events, and when I attend those events, I'm able to see the new innovations, new technology that's coming up, which I can apply in my line of work. The other thing is highlighting the benefits to everybody in the company and through education. Now, the reason why this is very key, because what happens is a lot what happens is not everybody is willing to listen to the other, and this can be a sort of a negative thing, because if you're not willing to listen, then it just goes to show you're not willing to embrace the new technology. Hence why I believe there must be some sort of middle ground to sort of give something a chance and see if it would benefit the company in the long term. Thank you for listening to me, and I'll take any questions.